We're looking at piecewise functions. Specifically, this video will deal with graphing them. Piecewise functions are functions defined by two or more equations. Each piece applies to a different part of its domain, and the domain are the x values that are being used. So we're going to graph this function. This is not proper piecewise function notation yet, but this is what a piecewise function is. It's you're taking two functions, putting them on the same graph, but only using a specific set of x values, which is the specific domain. So our first equation, f of x equals x plus 3. My graph's, my y-intercept is positive 3, and my slope is up 1 over 1. So I'm going to draw this line. Okay, now my domain tells me that the part of the function I want are the values that are greater than, but not equal to 0. So I'm going to keep all of the numbers that are greater than. So I'm going to keep this half of the graph, starting at the y-axis and going to the right. So this is what I want to keep this part, and I will erase everything on the other side. So I'm going to start here and just erase the rest of that graph. Now, because it just says greater than, not greater than or equal to, I'm going to change my endpoint to an open circle at the 3. So there's the first part of our function. Now my second function is g of x equals x. This is the line that has a y-intercept of 0, 0, and a slope of 1. We'll draw this line, and then we'll decide which part of the graph we want to keep and which part we want to erase. So your domain here is all the x values less than or equal to 0. So if I look at the x-axis, that's this set of values. So I'm going to erase everything on the positive side of the y-axis. Delete these, and since it's or equal to, I can leave that as a closed circle. And this is our function. This is our piecewise function. Now proper notation writes it as one function with one name, f of x, and then the letter doesn't really matter. It could be g, it could be h. We use a large curly brace, and we put the first function, x plus 3, if, and then we write our domain, x is greater than 0. Sometimes it'll say when instead of if, and sometimes if it will just have a comma. And then our second function, x, if x is less than or equal to 0. So this is our this is our proper notation for piecewise functions. So let's look at another example. Take a second and pause the video and write this set of equations as a piecewise function. Okay, so let's see. Did you get g of x? Again, the name doesn't matter. G, H, F, and a curly brace. Negative 2x minus 3. If x is it's greater than or equal to negative 3. And 3x if x is less than negative 3. So here, that is our proper notation. Now again, take a second, pause the video, and try to graph it on your own before you see me do it. So our first function, I'm going to do this part in blue, negative 2x minus 3. So I start at my y-intercept of negative 3. And my slope is negative 2, so I'm going to go down 2 over 1. Now I'll draw my line. Now my domain says I want the x values that are greater than or equal to negative 3. So that's about here and this way. which puts my open circle at -3, or my closed circle for this one, about here. This is going to be actually on this point. My line got off a little bit. So I'm going to erase everything to the left of that point. Tweaked my line a little. So that's the first part of our function. The line got tweaked a little bit. Let me redraw that because the slope got. There we go. Put my arrow on it. This starts here and goes this way. It's a negative slope. Now the second part of my graph is the 3x function. So I will graph that in red. 3x has a y-intercept of 0. Let me just erase this highlighting real quick. There we go. So 3x has an intercept of 0, goes up 3 over 1. Then I could go down 3 and to the left. My slope is positive, so when I graph this, I need to make sure from left to right the graph is increasing. Draw my line, and then we'll figure out where we need to delete and what we're going to keep. So my domain says here x less than -3, so that's about there. That's where my highlighting is. So this line, I'm going to have an open circle on it because it's just less than, not less than or equal to. And I'm going to delete all the way up to this open circle. We'll redraw in a sec. So I'm going to erase everything to the right of x is -3. And somehow let's see. We're going to redraw. My eraser's being finicky. Oh, that's not where I want to start. This is where my open circle is, right here. At x is -3. The line's going to go this way. So I want you to notice that my domain is all real numbers. This one encompasses equal to -3 and greater than, and this one is less than -3. And because these numbers are the same, my solid circle and open circle are on the same vertical line, and that line is at -3. If these numbers were different, then they might not overlap like that. Okay, and that's how we graph piecewise functions.